Well, hey guys, welcome back. You currently join me as I'm finishing up making one of those extended inverted live centers for the lathe. This is going to be for turning up a set of pins for some die wrenches that I'm making, and we'll touch on those in an upcoming video, that is if I manage to get them done. But for the moment, I want to talk about the press which I'm using to actually press in the bearings and the center cone. I'm sure you remember me making this, but this is effectively just a hybrid between a screw press and a fly press. That weighted handle means I can build up momentum on the round block, and the finer pitch means it's capable of doing more than 5 tons of force. It's definitely not as much as a hydraulic press, even a small hydraulic press can get up to 10 tons, but it gives you much better feedback and control when you're actually pressing something in, which I think is a really important quality to have when you're pressing stuff in. This is easily my favourite thing that I built in the workshop, just from the fact that it's a pretty unique piece of kit, and I always get a kick out of using it. But I think it's really easy to forget the amount of pre-planning and time that it took to get this done. Most of these projects that I do have some amount of pre-planning, but this one here was just off the charts. I think it was about 10 months, and it spanned about 10 to 12 videos, plus me getting a new lathe. That easily comes out to being 4+ hours of runtime if you were to watch all those videos. So what I'd like to do in this video is take you through from the start to finish, and what we'll try and do is link up all the small projects and finish with the fly press. So we'll start off back in January 2023 when the design started to come together. I'd always wanted a fly press, but it was only at that point at which I thought I'd have all the equipment and the skills to actually make one. The plan was simple enough. Build a fly press that's small enough to fit in the workshop and doesn't weigh several hundred kilos. Now that does sound simple enough, except fly presses are usually made from large steel castings or are forged, and I really can't do that, at least on the budget that I'm working with. As a result, everything needed to be made from welded up pieces of steel. Now realistically, the largest pieces I could get my hands onto, without running into minimum water quantities, was this 75mm square bar and 150 by 50 flat bar, and these would effectively dictate how large the press could realistically be. Now it took a bit of messing around in SolidWorks to find a shape that would work best. There's no quick guide on how to actually make these, so I was effectively just messing around to see what might work and what wouldn't work. Now the original design that I liked the best just wasn't deep enough to make a usable press. The frame that holds the round block attaches to the back of the frame, and the stock that I was using just wasn't deep enough to make a usable press. So I had to shift the design of the column forward, which gave me an extra 40mm of depth on the press. Once that was decided on, the rest of the plan was pretty straightforward. But I couldn't start to make the press until I'd figured out if I could make the screw and its corresponding threads. Doing this was definitely the biggest challenge and the biggest unknown, because the largest thread I'd made up until that point was probably M12, and I would be needing something that was probably 3 or 4 times that at a minimum. If I couldn't make that, it was probably game over long before I'd even started. So step 1 was to see if I could even manage to machine anything that long in the lathe. Now the answer was a solid maybe. I mean, the stock physically fits in the lathe, but it was anyone's guess as to whether I could actually machine something that long. So that's when I decided to make the steady rest from a piece of hollow bar. The lathe never came with one, and if I was going to machine something this long, I definitely need all the rigidity that I could possibly get. Now, given that I'd never made one of these before, I think it turned out pretty good. I was able to machine these full-length bars, although not quickly, but the point is I could definitely do it. Unfortunately though, that was only half the job done, because getting a thread profile cut was another story. Trying to cut normal threads at the best of time takes a lot of rigidity and power from your lathe, and unfortunately, because I am using this as a power screw, I'd be cutting Acme or trapezoidal threads, rather than the normal V thread, which is what I'd normally use. Acme threads are a lot more efficient for power transfer, and unfortunately, cutting these types of threads does take a lot more power and rigidity. So it's probably no surprise that the old mini lathe just wasn't rigid enough to cut even a small Acme thread. All I was ending up with was a chattered mess. Even worse, I was also tearing up gears trying to extend the lead screw so that it could cut a pitch up to 6mm. As much as I used to love pushing the mini lathe just wasn't designed to do this type of work, so I eventually needed a new approach. Now, I remembered watching an Ox Tool video from a while back where he connected a dividing head to a stepper motor, which was in turn controlled by an encoder linked to the mill table. Essentially, moving the table would spin the dividing head, which would allow you to mill these high-pitch helixes, which is essentially what I was trying to do here. Now, despite having done CNC conversions before and already having a CNC conversion kit already made for the dividing head, it would probably need a larger stepper motor and controller if I wanted it to work in that sort of manner. The small stepper motor which I was using before was already working pretty hard, and I doubt it would be able to rotate the dividing head whilst the workpiece was being machined with an end mill. Thankfully though, by sheer luck, the distance between the spindle on the dividing head and the lead screw on the table meant I could perfectly fit in two 45 and two 90 tooth gears into the space. Doing this links up the dividing head and effectively allows me to drive it off the table's lead screw. Doing this also gives me an effective pitch of 8mm, which is in the range of what I was hoping to cut. So the first thing I had to do was make up all the gears that I'd need. I then had to make an expanding mandrel to fit in the back of the spindle, which would allow the dividing head to be driven by the gears. After doing that, it was effectively a matter of connecting the gears to the lead screw clutch, and then we were good to go. The first test was done in acetyl plastic and it turned out pretty good, but the real test was going to be whether this would work in steel. And let's just say, it definitely wasn't easy or fast, but it did seem to work. Thankfully though, once it was done, it all cleans up nice enough to make a very usable thread. The big change though, compared to the original design, is that the end mill leaves you with a square profile versus the original trapezoidal profile, which I was going to go for. Now, no one uses these square threads anymore, just because Acme is a lot stronger and a lot easier to make. But in the grand scheme of things, it really wasn't worth getting too caught up in trying to turn this into some sort of trapezoidal thread. They're both going to be better suited for this than a regular V thread, so this is going to work just fine. So with the main shaft now made, I now needed a way to make the corresponding internal threads. Now by this point I got in the new lathe, but unfortunately it was out of the question, because the gearbox in the new lathe maxes out at about 3mm pitch, and trying to modify the gear banjo to change the pitches that I can get out of the gearbox is needlessly more complicated than it really needs to be. So effectively the only other method to do this was to make up a set of square thread taps, and I had to make them myself because they're generally not sold, and the size and the pitch that I was using was fairly non-standard. So step 1 was to get some big bars of steel and get them cut down and then turned to shape. Now all of them have about 3 degrees of lead in, and that is going to be a lot shallower than any other tap that you can find. Now the thing with these square taps is that, like a regular tap, they come in sets of 3, but the big difference is that each tap is going to get progressively larger and it will cut a larger diameter than the one before it. So the first one only cuts an outside diameter of 35mm, the next one has an OD of 37.5mm, and then the final one takes it to the full 40mm. And you have to do it this way because you're removing so much more material than you would with a normal tap. And I know in some larger sizes, I've seen these taps come in 5 or 6 tap sets. Admittedly, I would have probably liked these taps to have been a little bit longer, but this was definitely the limit given the size of the mill table that I have. I then had to machine in the flutes so they could cut the thread profile. The final thing left to do was to get these hardened. Now I'd used mild steel to make them because I wasn't sure how well this setup would handle high carbon steel. The only real downside to that is that the low carbon steel needs more carbon to effectively harden and be useful as a cutting tool. Thankfully what we can do though is seal the taps in boxes with charcoal and sodium carbonate and heat it in the furnace for a few hours. This effectively diffuses carbon into the steel and raises the carbon content, which then allows us to harden it. The only real downside to that though is it is not a quick process. I think I gave it at least 6 hours before quenching it, and I think I could have probably given it a few more hours. The taps then needed some clearance ground in behind the cutting edges, and then they were good to go. I think they turned out looking really great, but I can never get over the fact with just how comically large they are when you pick them up. Now, I did the first test in a piece of aluminium with a shifting spanner as a tap wrench, and I could immediately tell that this was not going to be an easy job. Aluminium is generally quite easy to tap, but this was putting up a real fight. If you look at the chips that we're making, you can see that some of those chips are pretty large, and you can only imagine the force that's needed to shear them off and make those chips. However, in the end though, we did manage to get there, and to my surprise, the thread turned out looking a lot better than I thought it would. Those threads are definitely passable, but there is absolutely no way that I'd be able to make those in steel with this current setup. I could definitely tell that the adjustable spanner was going to break with any more force. So the next project was going to be to make a tap wrench that could match the size of these taps. Now in retrospect, I probably could have made the tap wrench a bit more basic and saved a bit more time, but I really wanted to make a comically large tap wrench to match the taps. And if I was going to do that, I might as well put a bit more effort into making a good design to make it. With the tap and tap wrench now made, before I could use it, there were a few other things that needed to be worked out before I could make the fly press itself. One such piece of tooling which I needed to make was a two-piece vise, because even my big vise was just too small to hold the 150mm wide bar of steel which I was planning on machining. And I couldn't use toe clamps either, because I needed to face the top of the part in one go. Thankfully making these is pretty straightforward, and I had all the steel to make it. And making them is straightforward enough. All you have to do is make the fixed end and a moving jaw, and both of them just bolt to the mill table. And once it's all made, setting it up is quite straightforward. You bolt the fixed jaw to the mill table, then you place the bar between the fixed jaw and the moving jaw, and the moving jaw just has to move a little bit to clamp it all in place. Now alongside the new vise, I was very keen to make up a new fly cutter as well, so I could fly cut the top of the piece in one go, which would leave a nicer and more uniform finish to the surface. You know, my old fly cutter, which I use all the time, can probably do 60 or 70 millimeters in diameter. The one that I plan to make can do just under 200. Now the main body, which will act as our flywheel to help preserve momentum, is going to be made out of a piece of aluminium. And this is more common than you'd think for these large body fly cutters. Now whilst this piece can physically fit in the lathe, I couldn't actually machine it, at least at first, because I didn't, and I still don't own a chuck that is physically large enough to hold it. So what I had to do was first clean it up in the milling machine, using a set of V-blocks which I'd made up earlier to hold it in place. Once the part was faced, I could then make a hole in the centre for an arbor, as well as a slot for a carbide cutter and its holder. Once that was done, it was simply a matter of getting a Morse taper arbor made and then fitting that to the fly cutter. It was only at that point that I could then get it directly fitted into the lathe spindle and machine down the outside and the bottom face. And once the holder for the carbide insert was made, the fly cutter was finally ready to get to work, as well as the rest of the tools that I'd made over the previous months. And of course, I'd made all of those specifically to make the fly press. So I guess let's finally get started. So the first step was to get all of the metal cut up. I got most of it in these large bars, but I had to get it all cut up before I could put it in the milling machine. Now the first thing I want to make is the base, which I decided to widen with the first pieces that I'd cleaned up. These will just be welded on each side, and I'm not really expecting them to take on a huge amount of load. But without them, the press was a little bit too narrow and it looked a little bit weird. But before I do that, I'll try and round off the front of the main part of the base, and because it's not exactly a critical feature, I can simply do it all with the angle grinder. With that now done, I can clean up the top of the base with the new fly cutter. I think it leaves a really nice finish, and I am certainly glad that I have a 3 horsepower motor on hand to do this with. And with it still in the mill, I'll machine in a through hole, and this will be so that broaches and pins can pass all the way through the press. I'll also add 2 tapped holes on either side, fixturing vices or jigs in place. The final big thing left to do was get a big square chunk removed from the back so I could get the main column fitted in and welded up. Now I could have milled it out, but I probably would have been here all day, not to mention I'd probably use up an end mill or 2 in the process. So the workaround that I'm going to do is I'll use the drill to drill a line around the outside, and then I'll cut the remaining tabs away with a hacksaw. I can then come in with an end mill and simply clean it up. Doing this was a lot quicker, and I was able to save that big chunk of steel for a future project. Once the back was done, I then had to mount it sideways because I ran out of travel on the table and I wasn't able to cut the T-slots, which would help with mounting parts in place. Now the T-slots here are probably a bit undersized for the job. You know, I probably could have gone with the neck sized up, but they do work quite well. With the base now done, I can now focus on getting the rest of the frame all made. And all of it was going to be made from this 75mm square bar stock. In one piece I had to drill and tap a set of holes, and they were going to be for the round block guides. In another piece, I'll bore a 32mm hole for the square threads to be tapped. Now I should mention that at this point I had no clue if this was going to work. I wasn't able to pre-test the taps in steel to see if they would work, so this was the moment I'd find out if it would work or if it would go wrong. And to be honest, there were so many ways that it could have gone wrong. The taps might have sheared, or I might have sheared the teeth in them. The force required could have simply been way too much for me. I think the vise could have very easily broken, or the bench could easily break. Wait a second, that actually happened. In any event though, even though I did break the bench, I managed to get it to work, albeit very slowly. You know, on and off, this took about 3 days to get it done. And thankfully by the end of it, I was left with a really nicely formed thread. With that now done, I could simply cut in some bevels, round off the corners, and get everything welded. And once that was welded up, I could then weld the column to the base. With the frame now made, I can now make the round block and the guides. Now since the round block will be driven by the screw, I needed a way to make the screw captive in the round block. And this can all be achieved by using a split ring. So the top of the round block is going to get a counterbore to accept the screw and the split ring. I can then start to make up the split ring. With the split ring now made, I'll machine in a step on each side of the round block, and this will be for the front of the guide rails that will hold everything in place. And whilst I'm at it, I'll also add some grooves for some oil or some grease. Although with that said, the grooves ended up being a little bit too deep for my liking. With that now done, I'll make up the guide rails, which keep the round block positioned. And that should all assemble like that. And with that now done, I can simply bolt it in place. Now the next thing I was going to do was add the screw, which I'd made a few months previously, but at the last minute, I decided to case harden the screw. Now I doubt that wear is ever going to be an issue on this press, but I was afraid that the mild steel housing and the mild steel screw was going to start galling under load. Hopefully with one of them hardened, the whole setup should be less prone to galling. The final thing left to do once the screw was done was to simply get a handle made with a weight at one end. Now the screw has a square drive, which is going to require a matching socket. Finally, I'll turn down some rod for the handle and get one end bent at 90 degrees. The final thing left to do was make up a weight which will give us our momentum and turn our screw press into a fly press. For a fly press at this size, I certainly wouldn't want to go lower than 10 kilos, and I think this cheap kettlebell was a good source of cast iron. You know, it's not good cast iron by any means, it's generally quite porous, but that really doesn't matter a whole lot in this situation. The final thing left to do was get it all painted and then get a frame made up for this to sit on. And that, ladies and gentlemen, is the finished fly press. You know, one day I would like to get this stand bolted to the ground, but apart from that one drawback, I am really happy with the end result. For me, it's just a nice piece of equipment to have in the back of the shop, and like I said before, I really enjoy using it. Now, like I showed earlier, pressing in bearings is a real strong suit for this press because you have so much control and feel over how much force you need to put into the press. You know, this press can do 5 tons, and that is certainly enough for most applications. Now, the big strength for me when using this is to cut keyways. You know, especially with the commercial broaches, there is a fine line between cutting and potentially snapping it. And thankfully, the press is really great at getting the perfect amount of pressure on it to get it to properly cut. Those commercial cutters are not cheap by any means, so the less breaking that I do, the better. And once you're able to cut keyways, it's not too difficult to index the cuts to create spline shafts. Also, for what it's worth, the press can pull as well as push. You know, that's something that most cheap hydraulic presses can't do. And as a result, you can use pull broaches, which are a lot less likely to break. And that's about it for now. I hope you enjoyed this retrospective video on the press. At least to me, it feels crazy just looking back on it, just to see how much pre-planning and work had to go into this project, especially considering that this project could have gone so wrong. Thankfully though, it didn't, and I am so happy with the end result. Thanks for watching. See you next week.